Welcome to Module 5. The goal of this module is to show you how to create a scatter plot for your process data portion of the report. Now notice not every group will be able to, or every student will be able to create a scatter plot. It only applies to student experiments that created continuous or discrete data. If you don't know the difference between these, there's a chart here or a graphic to help you decide, or you can simply Google the difference. What we're going to create is a scatter plot, and you can see here they are used to show the relationship between two variables. So that is our goal, to determine whether our independent variable and our dependent variable have a relationship. Furthermore, on our scatter plot, we are going to include a trend line that will end up giving us a coefficient of determination, and I'll explain how that can be used to further discuss the relationship between our variables. You'll notice there's two notes here. For ease, we're going to, in our data worksheet, organize our data that we require in columns, independent on the left, dependent on the right. And we also need to create a scatter plot using our raw data. So we don't want to use our mean data that we've already done a little bit with. We want to use the raw data, and I'll show you what that means in terms of this table that hopefully you've seen if you've used the other modules. So for my set of data, my independent variable is the sucrose concentration. So I'm going to come over here and type this up. This is my independent variable, sucrose concentration. And I'm just going to wrap text for that easier to read. And then my dependent variable on the right, my dependent variable was the percentage change in mass. For you, it might be time. I know for a lot of enzyme people, it will be time. It really depends what your dependent variable is, but that belongs there. I'll make it a bit longer. Now you need to copy your raw data. Now remember, this will happen if you just straight copy and paste. So you need to go up to paste and paste your values. And for me, I want to round that to 2 decimal places so it matches my other data. So I'm going to right click, format cells, number, round to 2 decimal places, OK. My sucrose concentration, I can't come over here and copy it because you can see I've only written 0%, 10%, 30% once. That's not going to work for our graph. So you can see these 3 values all belong to 0%. So next to each one, I'm going to type 0. Notice I'm not typing percent because it's up here in my title, and we can't have any symbols next to our data when we want to create a graph. So I'm just going to pop in my independent variable numbers. This table is not going in my report. It's just for the sake of creating this scatter plot. I've created my table, and now what I can do is, so again, independent on the left, dependent on the right, and now I can create my scatter plot. So I can highlight all my data. I'm just going to do the data, not the titles. I can go insert. You can see this one here with all the lines. That's the one we want. The dots. That's our scatter plot. And you can see our scatter plot is being created here. Chart title, I'm actually going to go up here and delete it, and I'll show you why. If you look on your report, the exemplar, you can see for a graph, the titles actually go underneath. So you would just go and type that in your report, and please take note of the wording of this on how to create yours as well. But it is important we have the X and Y axes labels. Now for me, with this version of Word, I can just hit the plus, hit axes titles, and you can see they appear. Not everyone has this version of Word, so you just have to go up to design, add chart element, and you can add the axes titles that way. Independent variable is the x-axis, the one on the bottom, and that is sucrose concentration. Notice in brackets I'm putting my units, very important. And this will be the percentage change in mass. Again, put your unit in brackets. On the OneNote, you can see we've got some general information about presenting data in graphs, and you can just check you've added all those elements. We've created our scatter plot, so that's not really, you can see a bit of a trend, but we want to make that super clear for the reader. So we're going to click on it and we're actually going to add a trend line. So I'm going to go plus, you can find it up here as well, but for me it's easy here. I go trend line and I want to hit on this arrow and go more options. You can see it's automatically added a linear trend line for me. Some data created by some student experiments may be logarithmic, this curved, so you will just need to choose which trend line best fits your data. And it really depends on your understanding of the topic. But here you can see this linear line fits very well. Now, if I click on logarithmic, you'll notice that Excel won't even use that one for me. So let me just go back and add in the linear. Now I still want to go to more options, and that's because I click on the linear trend line, and as I scroll to the bottom, there's these two options I need to click on, which is display the equation on the chart and display the R² value on the chart, which is our coefficient of determination. And you can see they have appeared here for me. So I'm going to click out of that and save my work because I did not do that before. And what you would do is go ahead and insert that into your report up here and include your title. Then what you need to do is go through and do your interpretation and your analysis. Some points that you can make, and I just want to refer particularly to this R² value. Remember, we are discussing the relationship between these two variables. So I'm going to just get my notes up. So is there a relationship? I have a trend line, so yes, we can say, and you see it's very clear, so I can say yes. There is a relationship between these two variables. What type of relationship is it? You'll need to make that description. You'll notice as we double click our trend line, you can see it's a linear trend line. If you use logarithmic, you would use that word, or exponential going up that way. So I've got a linear trend line, so I want to include that in my description. Linear is just a straight line. And I can be more specific. It's not going up. If the line was going up, that would be a positive linear relationship. This is a negative or an inverse linear relationship between the two variables. So I can write that. There is a negative linear relationship between my independent and dependent. So between the sucrose concentration, and it was of the water in this experiment, and the percentage change in mass of the potato cube, I think it was. So I've said yes, there's a relationship, and describe that relationship briefly. And now what I want to do is talk about how strong this relationship is, talk about the strength, and that's where this coefficient of determination comes into play, my R² value. So I can say the strength of the relationship is, now to type R² doesn't work that well, so I'm just going to type it this way. Equals, what is the value? It's 0.8301, which implies, so the strength of this relationship is R² equals 0.831, which implies that this is actually a percentage number. So this is 83.01%. So I'm going to write that, which implies that 83, I'm just going to say 83% for ease, which implies that 83% of now it's the dependent variable, so 83% of the percentage change in mass of the potato is explained by the sucrose concentration of the water. So discuss, there is a relationship, I've described it, and now I've talked about the strength using my coefficient of determination, saying it implies that 83% of the dependent variable, the percentage change in mass, is explained by the independent variable, which is the sucrose concentration of the water. Very quickly, I want to make one more point. If you have a very clear outlier in your data, and you can see here, I definitely do, what you can actually do is create your chart, one including the outlier and one not including the outlier. And if there's a particular difference in your R-squared value, you are actually welcome to choose to use the graph that does not include the outlier, and just mention that the outlier is not included in your description. Thank you.